Okay. So these are all the problems we have to discuss today. I think we already finished question number 17. Am I right? Am I right?
Yes.
Yes.
Okay. So we just start from question number 9. Please listen each and every word clearly. What is given in the question? A small electric immersion heater is used to heat 170 gram of water for a cup of instant coffee. So that means you are going to prepare the coffee. For the coffee, you took the water, and how much mass of the water you took? You took 170 gram. So if you convert it to kilogram, this will be like this. Am I right?
-3, yes.
And then you are using the you are using the heater. The power of the heater is given. What is the power of the heater? The power of the heater is given as 180 watt. Now calculate the time required to bring all this water from 23 degrees Celsius to 100 degrees Celsius. So what you are going to do, you are going to heat the water. Initial temperature of the water is 23 degrees Celsius. You are going to increase the 23 degrees Celsius to 100 degrees Celsius. So for increasing from 23 to 100, how much time you take? You are going to take for heating the water from 23 degrees Celsius to 100 degrees Celsius. Clear? So you have the final temperature as 100 degrees Celsius. You have the initial temperature T1 as 23 degrees Celsius. Now, when you just know these two things, you can easily find the change in temperature as capital delta T, which is equal to 100 minus 23, which is equal to 77 Celsius degree, because we are finding the change in temperature. So by using these things, we are going to find the value of T. So we have two formulas for the power. Conduction rate. Am I right? How many formulas we have for the conduction rate?
2.
We have two formula. P, which is equal to Q over T, and also you have P, which is equal to Ka delta T over L. You have two formula. Am I right?
Yes.
How many formulas you have?
2.
Two formulas. So now out of these two formula, which formula you are going to use?
First one.
First one. So second one is not applicable. So I have to use this formula. And then we have Q term here. So how we can just use, because we studied the rule Q, which is equal to MC delta T. Am I right?
Yes.
So I'm going to take this. I'm going to substitute here. If you substitute, what you'll get? T, which is equal to MC delta T. That means T2 minus T1 divided by T you will get. So you have to rearrange this equation. Therefore, T, which is equal to MC T2 minus T1 divided by P. Am I right?
Yes.
So mass of the water is given in the question. T2 minus T1, that means change in temperature is given in the question, and then the power of the heat is given, and the specific heat of the water, this is a constant value. So what is the specific heat capacity of the water, my dear? The specific heat capacity of the water is 4189. Now if you substitute all the values in this given formula, you will get the answer. Am I right? The unit for the time is second. Clear?
Doctor,
Yes.
I have to convert the T to Kelvin.
No need, my dear. I told you in the classes, your Kelvin is exactly equal to Celsius degree. Do you remember that? Even if you convert
Yes.
into Kelvin, you will get the same thing. So why you are wasting your time? When you find the change in temperature, your Kelvin is exactly equal to the Celsius degree. Clear?
Clear.
Yes.
Okay. So answer is given here, but please have a look and please check the answer. Okay. Procedures are everything given clearly, but you can just check the answer. Now I think we already finished this question, so I can skip this. Let's come for 19th question. What is given in the 19th question? Read what is given. Consider the slab as shown in the figure. My dear, figure is given. This is your hot reservoir. This is the cold reservoir. you connecting these two reservoir with some slab. So you are taking this slab, so which connecting both reservoir. One is hot temperature, another one is cold temperature. Hot temperature is given. What is that value? Hot temperature is given as 125 degrees Celsius, and then cold temperature is given as 10 degrees Celsius. So now once you know the both temperature, you can easily find the delta T. Am I right? So 125 minus 10 gives you 115 Celsius degree. Am I right? Or Kelvin. Both are correct. Understand?
Yes.
Yes.
Okay. And then you take a material and you just connect the material between these two temperature reservoir, and that material is a copper. So what material you are taking? You take the slab. You take the slab as copper material. Am I right? So the slab is a copper material. So we are going to use, and the length of the copper material is given as 15 centimeter. So if you convert, you will get 15 multiplied by 10 to the power of minus 2 meter. And the area of the copper material is given as 105 centimeter square. So if you convert the centimeter square into meter square, you will get 105 multiplied by 10 to the power of minus 2, the whole square. So which is equal to 105 multiplied by 10 to the power of minus 4 meter square. Clear? Clear?
Clear, yes. Yes.
So by using this, what we are going to do, we are going to find the conduction rate. Again, the same formula. So P, which is equal to Q over T, or P, which is equal to Ka delta T divided by L. Which formula you are going to use?
The second one.
Second one. First one is not working here. So I have to use this as P, which is equal to Ka delta T divided by L. My dear, we are using the copper. So what is the thermal conductivity of the copper? This is a constant value. We will give that value. What is the temperature? What is the 401? So the value is 401. And what is the area of the slab? Area of the slab is given in the question. What is the change in temperature? Just before we find. Am I right? And then what is the length? 15, 10 to the power of minus 2. When you substitute the value, you will get the answer. What's the unit? Watt. Clear?
I can convert it to kilowatt. Or
my dear, leave the answer as it is, because I gave the answer in terms of kilowatt. Why? Because I got 10 to the power of 3 here. Am I right?
Okay.
So 10 to the better, no need to write these things. My dear, I think no need to write. Better write like this. Clear?
Okay, teacher.
From
where we got A?
What is this?
A, 105.
That is the area.
Oh, sorry. I didn't
is the
see
area.
It. Yes, thank you.
Clear?
Yes, clear.
Okay. Understand, my dear? My dear, all questions are easy in this chapter. The only thing you have to take the practice. Understand?
Clear, yes.
Okay.
Very easy.
Now, let's just read the question. What is given here? At what temperature is the Fahrenheit scale reading is equal to 3 times of Celsius scale? And the second question is 1/3 that of Celsius scale. My dear, what is exactly asking here? You have to give the temperature from Celsius to Fahrenheit. Clear? So you have to give the answer in terms of Fahrenheit scale. So what is given here? The first question, they are telling your Fahrenheit scale is equal to 3 times of Celsius. So that means F, which is equal to 3 times of Celsius. Am I right?
Yes.
What is given in the second question? Your F is equal to
X.
1/3 times of Celsius. Am I right?
Yes.
So first of all, I am going to consider the first question, and what you have to do, you have to give the answer in terms of Fahrenheit scale. So what I am going to do, I am going to make a small consideration. What I am going to consider, I am going to take Celsius. Sorry, I am going to consider Celsius, which is equal to X. I am going to take the Celsius as X parameter. Now, if you take Celsius as X, if you substitute the value here, what is your Fahrenheit, my dear? It's become 3 times of X. Am I right?
Yes.
Yes, you are.
Okay, now we have the formula for the conversion from Celsius to Fahrenheit. What is that formula? C over 5, which is equal to F minus 32 divided by 9. We studied this formula. Am I right? Now, could you please substitute these two in this formula in place of F and C? What you will get? This becomes x over 5, which is equal to 3 times of x multiplied by minus 32 divided by 9. Am I right? Am I
Yes.
right?
Yes.
So I can move this 9 to the left hand side of the numerator. I can move this 5 to the right hand side of the numerator. So this equation becomes 9x, which is equal to 5 multiplied by 3x minus 32. When you just multiply this 5 inside, this becomes 15x. This becomes 160. Am I right? 5 multiplied by 2, 10. 5, 3 is 15, 16. And the left hand side is 9x. Now what I am going to do, my dear, listen carefully. I am going to move this term to the left hand side. So then it becomes positive. I am going to move this 9x to the right hand side. That means I am going to separate x term one side. I am going to separate the constant one side. So what I will get? I will get 160, which is equal to 15x minus 9x. Am I right?
Yes.
So this 15x minus 9x becomes 6x, and this becomes 160. Therefore, my x, which is equal to 160 divided by 6, which gives you 26.6 degrees Celsius. Am I right?
Yes.
Yes.
Now, after you convert this value, because we have to give the answer in terms of Fahrenheit, so what you have to do, you have to take this value and you have to substitute the value of x here. So if you substitute the value of x here, what you will get? F, which is equal to 3 multiplied by x. What is the value of x? 26.6, which is equal to, when you just work out with your calculator, I will get 79.8 degree Fahrenheit. Clear? Clear?
Yes. Yes, sir.
Understand? My dear, in the same way, you have to work out with the B part. Again, I'm going to take the same thing. What is that? I'm going to take my Celsius, which is equal to x. I'm going to put this x here. Therefore, my F becomes x over 3. Am I right?
Yes.
Now you have to use this formula C over 5, which is equal to F minus 32 over 9. My dear, substitute the value of C here, substitute the value of F here. Again, please rearrange this equation. You will get the value of X. Understand? So you have to practice this. It's the same method. Understand?
Yes, that's sir.
Clear? In the same way, what I explained just now, what you have to do? Substitute the value of X here. So if you substitute the value, what you will get? This becomes x over 5. Am I right? Am I right?
Yes.
Yes, doctor.
And here, when you substitute the Fahrenheit, this becomes x over 3
3
minus 32 divided by 9. Am I right?
Yes.
Now move this 9 to the left hand side, move this 5 to the right hand side. When you just simplify this equation, you will get the value of x. You will get the value of x. Am I right?
Multiply by
Once you got the value of x, what you have to do? Take that value, substitute here. So F, which is equal to x over 3, and you will get the answer in terms of degree Fahrenheit. Clear?
Yes.
Clear? So the explanations are given here, but you take the practice, because same method. Why I have to waste my time? That's what I explained the first part. So you have
teacher,
to work out with the second part. Yeah.
the main formula is C over 5 equal F minus 32 over 9.
This is the main formula.
Okay.
This is the main formula we studied in the first slide.
Yeah.
What is this?
In order to find the
Clear?
Fahrenheit. Correct.
Yes. This is the formula for converting Celsius to Fahrenheit or Fahrenheit to Celsius. Clear? Understand?
Yes, very easy.
Okay. Let's come for the last question of this chapter. My dear, read each and every word very carefully. What is given here? A circular hole in an aluminum plate. So you have the circular shaped aluminum plate. And what is the diameter? The diameter of the aluminum plate is 3.115 centimeter. That means I have a circular plate of aluminum. The plate is made up of aluminum. And what is its diameter? The diameter is given as, I'm going to take diameter D0. What is the diameter of the aluminum plate? 3.115 centimeter. Clear? So when you take the diameter of this circular plate, circular aluminum plate, I will get 3.115 centimeter. And what is the temperature at the time? What is the temperature at the time?
0.
0 degrees Celsius. Now, what you are going to do, you are going to heat this aluminum plate to 180 degrees Celsius. How much temperature you are going to heat?
180.
180 degrees Celsius. When you heat the aluminum plate, what will happen? What will happen, my dear?
Will be
Its
decreased.
diameter remains the same or it change?
No, change will be changed. It
Yeah.
will decrease.
What we studied the concept of thermal expansion. For sure, the diameter will get increased. Am I right?
Yes.
So we have to find what should be the final diameter after you heat the plate to 180 degrees Celsius. We are going to find the value of dF. So, my dear, we studied three relations: linear expansion, area expansion, volume expansion. So, for solving this problem, I am going to find the linear expansion equation. What is that linear expansion? Delta L, which is equal to alpha L naught delta T. Am I right?
Yes, yes.
So, my dear,
Yes.
this alpha is for the aluminum. Am I right? What material?
Aluminium, yes. It's,
Aluminum. So, I am going to replace this equation in terms of diameter. What you will get? D delta D, which is equal to alpha of aluminum D naught
D naught.
T2 minus T1. Am I right?
Yes.
So, now what is delta T, my dear? My delta D is nothing but D final minus D initial. That means D initial 0, which is equal to alpha AL D naught T2 minus T1. Now we are going to find the value of this DF. When you just move this minus D naught to the right hand side, this becomes plus. Am I right? So DF, which is equal to alpha AL D naught, I can just write D2 minus, so T2 minus T1, and this positive, this negative, when it goes to the right hand side, this becomes
Positive.
positive. Now you can see what is the value of this alpha aluminum. My dear, this is the constant
23,
for aluminum. What is the value of alpha?
23 multiply
23. What is the initial diameter? The initial diameter is already given in the question. What is that value? 3.115 centimeter.
3.115.
And my dear, please convert the centimeter to meter after you got the answer. Clear? Understand?
yes.
Okay. And then T2 minus T1. 180 degree. What is your delta T, my dear? 180 degree minus 0 degree. What is the answer? 180 Celsius degree. Am I right?
Yes.
Plus D naught. So when you substitute all the value here, you will get the answer of your final diameter. Am I right?
Yes.
So you will get the answer. The same informations are given here. So please take practice. Understand?
Teacher, the D naught or D initial, they're both the same value, correct?
Yes, of course. You have to directly substitute the value of D naught.
And we change it to meter.
No, my dear, later on, my dear, after you find the answer, please convert it to meter. First, you just work out with a centimeter. After you find the answer, then convert. Otherwise, what will happen? There may be some chance for making some mistakes. Am I right?
Okay, okay.
Doctor,
I have
It's up to you. If you want to convert initially, no problem.
Doctor, for
Clear.
sure it will be bigger. DF, it will be bigger.
Yes, of course, it's bigger. It's bigger. My value is 3.115, and here I got 3.128. Whether it's smaller or bigger?
Yes, yes.
It's bigger. It's increasing. Am I right?
Yes, yes.
Yes,
Doctor?
that's it. Problems of chapter number 18 is over. Yes, my dear.
I have two questions, if I may ask, just to make sure. So
Yes, please.
After-
Yes, please. Ask your question.
after we rearrange the equation, we will have 2 D naught, right?
Yes. If you
Okay,
want to
and
take a common, no problem. For example, you can see this. If you take D naught as a common, what is inside? Alpha AL. This becomes delta T. Am I right?
Yes.
This will come like this. Am I right?
Yes.
So you can use this equation also. You will get the same answer. If you use this and this, you will get the same answer. Both are same.
Okay, clear. Thank
Clear?
you. Yes.
Clear. Yes, Doctor.
What is your second question?
That's it. I understood. Thank you.
That's it. So because you told me two questions you have.
Yeah, that you explained.
Okay, that's it. My dear, chapter number 18, problems are over. Now what I am going to do, I am going to take chapter number 19. And my dear, please listen carefully. This chapter is very big. At the same time, we are going to use many formulas and all the informations are given here. The only thing I need your concentration. My dear, the only thing I need your concentration. So please listen carefully. The title of this chapter is Kinetic Theory of Gases. That means this chapter is also related with the thermodynamics. That means you can say this is thermodynamics second part. So whatever the things we studied in chapter number 18, we studied the outline of thermodynamics. Am I right? Am I right?
Yes.
So in this chapter, we are going to see all the information minutely. That means we are going to see the micro level information about the chapter 18. So chapter 18 tells you about the macroscopic point of view. Chapter number 19 tells you about the microscopic point of view. Do you remember that in chapter number 8, we conclude the classes with special cases? Am I right?
Yes, Doctor.
So what is isothermal, what is isobaric, what is adiabatic, what is first law of thermodynamics? So we are going to use all this information in this chapter 19. So please, my dear, listen carefully. It's one of the important chapter and we are going to solve 6 questions in this chapter. Inshallah, I will try to finish the theory today because it's nothing. And once I just finish, inshallah, we have to solve the problem tomorrow. Understand? Okay.
Yes, Doctor.
What are the topics we are going to discuss today? These are all the contents. My dear, out of this content, these 3 points are very, very important. So we are going to study the general information about the ideal gases. You already know what is the ideal gas equation. Am I right? The ideal gas equation is PV, which is equal to nRT. You already studied this equation in your chemistry as well as in your school life. Am I right?
Yes.
So today also we are going to use this relation in many places. So please listen carefully. And if you just see the second point and third point and fourth point, these 3 points are very, very important. And we are going to solve many questions from this. That means out of this 6 questions, maybe 5 or 4 questions from these 3 points. So please listen carefully. We are going to study the concept of pressure equation for the gas, temperature, as well as the root mean square speed of the gas molecule, or MS stands for its root, M stands for mean, and S stands for square. So root mean square speed of the gas molecule. And after that, we are going to study the molar specific heat. My dear, we have 2 molar specific heat. One is based on constant pressure, another one is based on constant volume. So here CV stands for molar specific heat at constant volume and CP stands for molar specific heat at constant pressure. So please keep these 2 parameters very carefully. CV stands for molar specific heat at constant volume and CP stands for molar specific heat at constant pressure. And then finally we will conclude this session, this theory class, this chapter with adiabatic. What is adiabatic? We already know. What is adiabatic, my dear? What is adiabatic?
No heat
no heat transfer. So
Yes.
if you just see, we are just going from macro level world to the micro level world. That means in chapter number 18 we studied the concept of thermodynamics outlinely, but now in this chapter we are going to study the concept, that means the internal parameter of the gas molecules. So please listen carefully. The first slide, we are going to start from Avogadro number. My dear, everybody, we know the concept of Avogadro number. Am I right? The name of the scientist is Avogadro. Actually, his name is very lengthy, but generally we will just call him as Avogadro. Actually, he is an Italian scientist and he used one number, and that number everybody will know. This indicates the number of atoms present in each and every element. If you take a periodic table, If you just see 1 mole of silver atom, silver molecule, silver element consists of 6.02 multiplied by 10 to the power of 23. So every time we have to use this 1 mole of the particle compare with the 12 grams of carbon 12 atom. So every time we have to give the definition based on the carbon 12 atom, because carbon 12 atoms is the stable. We have to take this carbon 12 atom as the reference. That is not matter today. We are going to get the number. This is the constant number for finding the Avogadro number. Avogadro number is not a small number. It is a very, very big number. Am I right? Am I right or not?
Yes, doctor.
Yes,
So
sir.
in our day-to-day life, for example, if you go to the grocery shop for buying grocery shop or market to buy the egg, so we can ask, give me a dozen of egg. What is meant by dozen, my dear?
12.
What is meant by dozen?
12.
12.
12 eggs.
Dozen stands for 12. So for example, if you take the case of a Coca-Cola tin, a case consists of 25 tins. Am I right? Am I right or not?
Say that again.
My dear, if you go to the shop to get the Coca-Cola tin, the small size tin, if you take a case consists of 25 number of tins. Am I right?
Yeah, yes.
So likewise, if you want to mention the number in the periodic table, that's what Avogadro gave this number. If you take each and every element in the periodic table, each and every element consists of this many atoms in that element. So that's why we are using this big number. In our day-to-day life, if you want to use this number, it's not possible because this is a very huge number. Why we are using this number? We have to use this number only for the electron, atoms, molecules. When we just go for the small size elements, by the time we can use this Avogadro number. Because this topic, we are talking about the kinetic theory of the gases. The gases consist of n number of molecules. By the time we can use this Avogadro number. Clear? Because the size of the gas is very small. Am I right? Is it possible to see the gas molecule?
No, doctor.
Is it possible?
No.
That's why we are using the Avogadro number for the calculation purpose. So now that's not a matter. We are not going that much deeper into Avogadro number. The most important thing, we are going to use these two formula. My dear, if you want to find the n number of moles, n stands for the number of moles. You can see here, I clearly mentioned here. What is n? N is the number of moles. Suppose if you want to calculate the number of moles in the given sample, you must use the number of molecule as well as the Avogadro number. That's what we are using the Avogadro number here. Once you know the number of molecules, once we know the Avogadro number, we can easily find the number of moles present in the given sample. Likewise, if you want to find the molar mass of the sample, you must need two things. The first one is the molecular mass, small m, and then Avogadro number. So these two formula we are going to use in the forthcoming slides for some calculation purpose. So our first two formula from this slide is calculating the number of moles from the sample and also calculating the molar mass from the sample. So please, my dear, keep this formula in your mind. Please memorize this because we need this for some calculation purpose. Understand? Clear?
Yes, doctor.
Okay. Now, when we come for studying the concept of ideal gas equation, we must remember these two laws. The first one is Boyle's law and the second one is Charles' law. My dear, here we know the formula for gas equation. What is the gas equation? PV, which is equal to nRT. P stands for pressure, V stands for volume, and T stands for temperature, and this N is the number of moles and R is the gas constant. So if you want to work out with these things, these three parameters are very, very important: pressure, volume, and temperature. Now, when you study the concept of Boyle's law, you can just see the picture. I have a container, and the container has how many volume of gases? I have 1 liter of gas or some molecules I have. Am I right? And now, what is my pressure? Initially, I have the pressure at the room temperature. Now, if I increase the pressure to the piston, what will happen, my dear? My volume get decreased. Am I right? Am I right or not?
Yes.
At room pressure, no change in the volume. But when you give 2 atmospheric pressure, according to this diagram, what happened? Your 1 liter container is converted to half liter. Am I right?
Yes.
So what is exactly happening here? When you increase the pressure, what happened to the volume? The volume get decreased. Am I right?
Yes.
At your, what is your temperature? What is your temperature?
Constant.
Constant. At constant temperature, when you increase the pressure, if the volume get decreased, then we have to say that loss is the Boyle's law. Clear? Likewise, when you come for the next slide, that means Charles' law. My dear, this is your experiment for this week or next week. We are going to practice this Charles' law in our lab. So what you understand from this Charles' law? Again, just have a look of this picture. I have a container and the container is attached with the piston, and inside the container I have some gas molecules, this black color dot. And initially my temperature is T1. Now what I'm going to do, I'm going to increase the temperature. When I just increase the temperature, what will happen? This gas molecule get increased and it will push the piston in the upward direction. Am I right?
Yes.
Am I right?
Yes.
So what is my volume, my dear? Here my volume is small, here my volume is more. Am I right?
Yes.
So here my temperature is small value. When I just increase the temperature, my volume get increased. That means whenever you are increasing the temperature, my volume get increased. That means the temperature has the direct relation with the volume. But what is your pressure?
Constant.
What is your pressure?
Less.
Constant. Clear? So you have to compare the Boyle's law and Charles' law. Sometimes we may ask the question in your knowledge part question. The definition. If the temperature is direct relation with the volume, what is this law? You have tried, it's a Charles' law. Clear?
Can you
Clear, my
repeat it,
dear?
sir? Can you repeat?
When the temperature, when you increase the temperature, for example, when your temperature is exactly direct related with the volume, for example, when you increase the temperature, your volume get increased. When you decrease the temperature, your volume get decreased. Clear? Direct relation. In such a case, that is Charles' law. What is your Boyle's law? When you increase the pressure, your volume get decreased. Am I right or not?
Yes.
Yes, Doctor.
So this is Boyle's law. This is Charles' law. Clear? Clear,
Yes.
my dear?
Yes, yes.
Okay. Now we come for studying the basic equation, the general equation for the gas molecule. So we know the ideal gas equation, PV, which is equal to nRT. My dear, listen carefully. This is also the ideal gas equation. But how we got? If you write this equation or this equation, both are exactly correct. For what we did here, because I just write the general equation. My dear, in the first slide, we studied this formula. Am I right?
Yes.
If you take this n value, if you substitute here, your equation will be like this. Am I right?
Yes, you are.
Now, this R over NA is called as Boltzmann constant K. R divided by NA is nothing but K value. So, when you replace this R over NA with K, your equation will be like this. Am I right?
Yes.
So, R is the constant. It's a gas constant value. Na is the Avogadro number. When you use this, the Boltzmann constant have the constant value as 1.38 multiplied by 10 to the power of minus 23 joules per Kelvin. So you have to write either this equation or this equation for the ideal gas equation. Understand?
Yes.
Clear, my dear?
And
Clear, yes.
Doctor,
Ah.
the capital N.
Capital N. What is this capital N? Number of molecules. What is this capital N?
Yes.
Clear?
Molecule. Yes.
Okay. Now we are going to work out with this type of special cases. What is isochoric? What is isobaric? What is isothermal? My dear, isothermal is called as constant temperature. If you have a constant temperature throughout the reaction, then you have to say the process is isothermal. Suppose if you have a constant volume, what is isobaric? Isobaric means constant pressure. So whenever your pressure is constant, then you have to say this is an isobaric. Clear, my dear? Whenever you have a constant volume, then you have to say it is an isochoric. So we are going to deal with these three parameters in the forthcoming slides. Clear? Clear, my dear?
Clear,
Doctor,
yes, yes.
Yes.
constant volume. We
Ah,
take it before.
my dear, constant volume means what is that? There is no work done. Am I right? If you have constant volume, there is no work. Am I right?
Yes.
If there is any work done, then we have to use this formula. What is the formula? P delta V. Do you remember this formula we used in the last chapter?
Yes.
Yes.
So
For
we
the work.
are going to again work out the same problem, same formula. So please listen carefully. My dear, you can just see this picture. Here I gave the explanation based on PV diagram. That means P stands for pressure, V stands for volume. What we are going to do, we are going to find the work done by an ideal gases under constant temperature. If you have a constant temperature, what will be the rule? So we know the general formula for work done. What is the formula for general formula, my dear? Work done, which is equal to pressure multiplied by change in volume. Am I right?
Yes.
Now, if you just see the picture,
Yes.
I have 3 green color lines. My dear, I have 3 green color lines. You can consider any one of the lines. So what I'm going to do, I'm going to consider this line. My dear, throughout the process from this point to this point, what is my temperature?
110.
That means I am not changing the temperature. My temperature is constant from the starting to ending. Clear? Understand?
Yes, clear.
So in such a case, how to find the work done? So if you want to find the work done for these gas molecules under constant temperature, we have to use this formula. My dear, W, which is equal to P delta V, I can write as dV. Am I right? Am I right or not?
Yes,
Small
you're right.
level change in volume, small level change in the volume. Big level, we have to use delta V. Small level, I have to use dV, small fraction by fraction. Clear? So if I use this formula, if I integrate from the initial volume to the final volume, my dear, listen carefully. I have to use the ideal gas equation. What is ideal gas equation? PV, which is equal to nRT. Therefore, my P, which is equal to nRT divided by V. Am I right?
Yes.
Yes.
I am going to take this. I am going to substitute here. If you substitute, I got this equation. Am I right?
Yes.
Yes, doctor.
So now, what are the constant terms you have here? My dear, initially we told our temperature is constant. Am I right? Isothermal, constant temperature. N is the constant value. R is the constant value. So I can take these things outside. Am I right?
Yes, right.
Am I right? So if I take it outside, what are the things will comes outside? N, R, T outside, it will be coming. What is inside? dV over V is there. Am I right? And what is your range? Initial volume to the final volume. Clear?
Yes.
So now, if you integrate this dV over V, what you will get, my dear? I think mathematics you will study. If you integrate this dV over V, you will get natural log of V final minus V initial. Am I right?
Yes, you are.
Am I right or not? So logarithmic rule, how you can write? You can write the logarithmic rule as V final divided by V initial. Am I right or not?
Yes.
Yes, you're right.
So in this place, I can just take it and substitute. So finally, my answer is work done, which is equal to nRT natural log of V final over V initial I got. Am I right?
Yes.
Okay. Now, at constant volume, if the volume is not changed, what is this work done, my dear?
Zero.
If there is no change in the volume, there is no work done. Logically, you can think, if the volume is not changed, for example, your body has, my dear, for example, my body is 70 kilogram. I want to reduce my body weight. So I have to do some exercise. Am I right?
Yes.
So for example, my body weight is not reducing. It's exactly the same. That means my work done is exactly equal to 0. Am I right?
Yes.
Yes.
So at constant volume, if there is no change in the volume, then you have to consider my work done is 0. Suppose if there is any change in volume, so you have to use W is equal to P delta V. Clear? Clear, my dear? Here the pressure is constant, but volume is changed. And here the temperature is constant, so we have to find the work done. So you have two work done. If the constant temperature will be there, you have to use this. If there is a constant pressure, you have to use this. Clear? So you have to read the question very carefully.
Clear.
Clear?
Clear, yes.
Okay.
So, Doctor, the last one, there will be only change in volume, but the pressure will be constant, right?
Pressure will be constant.
Okay.
Clear?
Yes.
Doctor,
Yes.
the first rule I used when he said constant temperature, right?
Yes. Constant temperature or isothermal, both are same.
Okay.
Clear? Okay. My dear, in this slide, we are going to study two important formula. So please listen carefully. And I just work out all the information here. If you just see step by step, you will get the clear information. So please, my dear, listen carefully, because for the forthcoming slide calculation, we are going to use some rule from this slide. So what is given here? I gave a picture of a box. So that means I have a box and its shape is exactly, all sides are exactly the same. That means the box is exactly cubical in size. Am I right? Am I right? What is the shape of the
Yes.
box?
Yes.
It's cube.
Yes,
That's what all sides are exactly the same. Now, inside the box, I have gas molecules. My dear, how many gas molecules I have inside? 1, 2, or 3. How many gas molecules I will have inside?
1.
My dear, gas molecule consists of n number of particles. Am I right?
Yes.
So, if you want to study the information directly from n number of molecules, it is very hard. Am I right? Am I right?
Yes.
So what I am going to do, I am going to explain the concept for only one molecule of the gas. After we find the relation, I am going to multiply by n, and that will be applicable for n number of particles. So for the time being, I have a box. Inside the box, I am going to take only one molecule of gas particle. Clear? Clear?
Clear. Clear.
Yes.
Okay, now listen carefully. All sides of the boxes are same length. Now, my dear, this gas molecule, this blue color dot, have the mass m, and it is moving in the direction of the x direction, so it has the speed v. Clear? So how many directions you have? Vx, vy, and vz. Am I right? Am I right or
Yes,
not?
doctor.
Please give a response, my dear. If I ask the question, please respond.
Yes, doctor.
Okay, now if you have the mass and the velocity, you can easily find the momentum. Am I right? We studied in chapter number 9, physics 1. So what is the formula for momentum? Mass multiplied by speed. My dear, here the speed of the molecule is exactly in only one direction. That's what I write Vx. So once you know the momentum value, you can find the change in momentum. Am I right? So what is change in momentum? Final momentum minus initial momentum. Am I right?
Yes.
Yes.
So what is your final? My dear, listen carefully. This gas molecule is going in this direction and it is coming back. After it hit the wall, it will be coming back. Am I right?
Yes.
So my final is in the positive direction. My initial is in the negative direction. Am I right?
Yes.
So final mvx minus of minus mvx. Am I right? So minus into minus become plus. I got 2mvx. Understand?
Yes.
Clear?
Clear, doctor.
Okay. Now, once you know the change in momentum, you can easily find the impulse. My dear, what is the formula for impulse? Impulse, which is equal to change in momentum. We already studied this rule in physics 1, chapter number 9,
Yes.
impulse momentum theorem, and which is equal to my average force, F multiplied by delta T.
Delta T.
Am I right or not?
Yes, sir.
So therefore, from this equation, I can easily find F value. That means F, which is equal to delta P over delta T. Am I right? That means change in momentum divided by time change. So what is my change in momentum, my dear? Change in momentum, we got 2 multiplied by mvx. And what is my time? Time rule we already know. What is time, my dear? Time, which is equal to distance over speed. Am I right?
Yes.
I right? How much distance it is traveling from this point to this point? It is moving L direction in this direction. It is coming back another L. So what is the total distance? 2L. Am I right?
Yes.
And it is moving in the X direction. So my speed is Vx. So here I have to replace this time variable as 2L over dx. So this 2 and this 2 get cancelled, and finally I will get this equation. Am I right?
Why too old, Doctor?
What?
Too old.
My dear, this 2, when the molecule is moving from this point to this point, it will travel L distance. Am I right?
Again,
Am
Doctor?
I right or not? Gas molecules moving from this point to here. Am I right?
Yes, you are.
And after it hit, where it will be coming? So it is going from here to here. Am I right?
Yes.
How much distance it travel?
L.
After it hitting on the wall, it will be again travel another L distance. Am I right?
Yes, yes.
So what is the total distance?
Too old.
So that's what I just tried. So we know the rule, time which is equal to distance over velocity, that means speed. So my distance is exactly equal to 2L. That's what we are writing, T which is equal to 2L over V. Clear?
Clear, Doctor.
So here 2 and 2 get cancelled, and then you will get this equation. Now, my dear, this equation is only for X direction. How many directions still you have? You have Y direction and Z direction. Am I right?
Yes.
Yes.
Am I right or not? So my general speed square, which is equal to Vx square plus Vy square plus Vz square. Am I right?
Yes.
So my dear, this is exactly the cubicle in shape. My speed in the X direction is exactly same like speed in Y direction. Am I right?
Yes.
My speed in Y direction is exactly equal to speed in Z direction. Am I right?
Yes.
So I can write my Vx, which is equal to Vy, which is equal to Vz. Am I right?
Yes, you are.
So this equation becomes, how your equation becomes? My equation V square becomes Vx plus Vx plus Vx square. Am I right?
Yes.
So what is the answer? My V square, which is equal to
3V.
3Vx square. Am I right?
Yes, Doctor.
So therefore, my Vx square, which is equal to V square over 3. Am I right?
Yes, Doctor.
So this V square is called as RMS or average speed square. So please keep this information. This V square is called as RMS square or average square. Both are correct. So now you can see here, I can just read in this place of Vx square, in this place of Vx square. My dear, listen carefully. Again, this line makes a problem. Here, in this place, what I am going to do? I am going to substitute this value. If you substitute this value, you will get the equation like this. Am I right?
Yes, Doctor.
Am I right?
Yes.
Yes.
So, my dear, listen carefully. This is the force equation for one molecule of gas. Suppose if you take n number of molecules, I have to put capital N in front. Am I right? Am I right?
Yes.
That's what I just wrote n here. So here I got 3L. Clear? So this is for n number of particles. Clear?
How Doctor got in?
My dear, this equation is for one molecule. Am I right? This equation is for one molecule. Am I right?
Yes.
If you have n number of molecules, you have to multiply n. That's it. Am I right?
Yeah, okay.
That's what I just multiply n here. So this is the equation for the force for the n number of molecules, which is equal to this equation m v square RMS multiplied by n divided by 3L. Now I am going to find the pressure from this force. We know the formula for the pressure. What is the formula for pressure? pressure which is equal to F over A. Am I right?
Yes.
So pressure for n number of molecules, which is equal to force for n number of molecules divided by area. So what is my force for n number of molecules? So this equation. So you take this Fn and substitute here. When you substitute, you will get this equation. And what is this L multiplied by L square? What is this L multiplied by L square?
Volume.
It's
Area.
nothing but volume. Volume. Area multiplied by L becomes volume. Am I right?
Yes, doctor.
Area is L square. Multiplied by L square is nothing but area is L square. Multiplied by L becomes volume. Am I right? Am I right or not? That's what I just write 3V. Now, my dear, listen carefully. We got this equation. We got this equation for n number of molecules. My dear, we already studied this small n and capital. So from this small n formula, we can find the capital N. Am I right?
Yes.
Yeah, yeah.
So take this n value and substitute here. If you substitute, you will get this equation. Am I right?
Yes.
Yes.
And here we know the rule capital M, which is equal to M multiplied by NA. And here you can just see this. We have M multiplied by NA. We have. Am I right?
Yes.
Am I right?
Yes. We can.
So this is equal to capital M. So I can write the equation like this. Am I right?
Yes.
Yes.
So, my dear, once I just got this equation, I am going to use this equation for the further calculation. So, my pressure equation, which is equal to this value. So, we know the general equation for the ideal gas equation, PV, which is equal to nRT. Am I right?
Yes.
So, therefore, P, which is equal to nRT divided by V. Am I right?
Yes.
So, take this P and substitute here. If you substitute here, you will get this equation. Am I right?
Yes.
Yes.
So now you can see here. This V and this V get cancelled. Am I right?
Yes.
This small n and this small n will get cancelled. Am I right?
Yes.
From this, I can find the root mean square speed square. Am I right? Root mean square speed we can consider. Am I right? So if you rearrange this equation in terms of V RMS square, I got this equation. Am I right or not?
Yes, doctor.
Now, if you want to find the V RMS value, what you have to do? You have to take the square root on both sides. Am I right?
Yes.
So square root of V square becomes V RMS, and this terms becomes square root of 3 RT. So this equation is very, very important for the calculation. Suppose calculate the root RMS square speed for the given temperature and the molar mass. If you give like that, you have to use this equation. You have to use this equation. Clear?
Yes,
Clear,
doctor.
yeah.
Clear?
Yes.
Clear, my dear?
Doctor.
All this based on the substitution. My dear, you can see every time we are just using this R, K value, small m value, capital M value, small n value. So these small equation frame the big equation. So you have to be very, very strong in the small size equation. That's very, very important. Understand?
Yes.
Okay. So we are going to use this equation for the VRMS. Now, you can just have a look at this slide. I gave some sample question. My dear, suppose we are asking you to find the RMS value for the given temperature and molar mass. Then you have to use this rule. Then you have to use this rule. Am I right? Am I right or not?
Yes, you are.
Suppose if the temperature and molar mass is not given, just only number is given. Now, if I ask you to find the RMS value for this number, how to find, my dear? I told you just before, VRMS. What is this S stands for? Square. What is this M stands for? This line is irritating me.
Doctor, you written
V R M S. What is S, my dear?
square.
Square. What is M?
Mean.
Mean. What is R?
Root.
Root. Okay. If you want to find the RMS value for the given number, my dear, listen carefully. You have to do like this. What are the numbers given here, my dear? What are the numbers given here? 5, 11, 32, 67, and
89.
89. 67 and 67 and 89. Am I right? We are going to find the RMS value for this given number. My dear, how to calculate this? My dear, go in the reverse way. Go in this direction. What is the first letter from this right side to left side? What is the first letter?
S.
Square.
That means what is the meaning for S?
Square.
Square.
So you have to square. You have to square each and every number. Okay.
Okay.
Clear? And then what is your second number? Second letter?
Mean.
What is mean, my dear? What is mean?
Median.
What is mean? What is mean?
The mid number.
Average.
Average number.
What is mean? What is mean? What is mean, my dear? I written here. Just tell me what is mean?
Average.
Average. So how to find the average of this number, my dear? You have to add all these things. Am I right?
Yes, over 5.
And then divide by
5.
5. Am I right? And
Yeah.
what is the last letter? What is the last letter?
Root.
Take the square root. That's it. You will get the same answer. So when you are finding the RMS value, you have to go in the reverse order. Understand?
Yes, yes.
Clear, my dear?
Doctor, we will
Yes.
find the N.
We are going to find the, my dear, here they just give the number. For example, I am asking what is the, calculate the RMS speed of this number. Clear?
Yes, yes.
You have to find whether it is N or RMS speed. You have to follow the same procedure. You have to follow the same procedure.
Yes.
Clear?
Yes, Doctor.
Okay. Now, my dear, listen carefully. Again, we are going to use the formula from this slide. So I'm going to take these two formula. I'm going to take these two formula. What is this formula? This is our speed RMS square. Am I right? So 3RT over M. So speed RMS square, which is equal to 3RT over M. Am I right? Okay, now by using this, we are going to find the average kinetic energy. My dear, there are two formulas for the kinetic energy. One is for average kinetic energy and second one for total kinetic energy. So don't get confused. Both are different formulas. So if you want to find the average kinetic energy, we know the formula for kinetic energy. What is the formula for kinetic energy, my dear?
Half mv square.
Half mv square.
Half mv square. So this v square is nothing but our RMS square. Am I right?
Yes.
Yes.
Because in the previous slides I told you v square, which is equal to v square average, which is equal to v square RMS. I told you. Am I right?
Yes.
So in this place, I am going to take this value and substitute. If you substitute, what you will get, my dear? This equation becomes half m 3RT over capital M. Am I right?
Yes.
So we got the same equation like this. Am I right?
Yes.
Now we know this rule, capital M, which is equal to small m multiplied by Avogadro number. I am going to substitute this formula here. If you substitute, you will get this term. Am I right?
Yes.
Am I right or not? Now, what is this R over NA?
K.
Ah, very good. So when you just replace this R over NA, we will get this equation. Am I right?
Yes.
So this is the formula for average kinetic energy. Likewise, if you want to find the formula for total kinetic energy, my dear, total means n number of, it is applicable for n number of molecules. Am I right? Am I right or not?
What, doctor?
My dear, total, what is the meaning for total? For example, if you want to find the total kinetic energy for all the gases, means the gas consists of n number of molecules. Am I right?
Yes.
So I have to multiply this n with the kinetic energy formula. Clear?
Yes.
Now in this place, in this V square RMS, I can take this value, I can substitute here. Am I right?
Yes.
If you substitute, what will happen? This m and this m get cancelled, and finally you will get this equation. Am I right? Am I right?
Yes.
Now we have k here. What is k, my dear? We have the k formula. So please substitute this. When you substitute, you will get this equation. Am I right? Am I right or not?
Yes. Yes.
So, and then we have n. When you substitute this rule, you will get this term. So when you just simplify this equation by using these two small equations, you will get the total kinetic energy of the gas molecules as 3 nRT divided by 2. So you have two formula. One is for average kinetic energy and the second one is for total kinetic energy. Clear?
Yes, doctor.
Clear?
Yes.
Okay. Now, my dear, this slide is very, very important. So please listen carefully. Most of the questions are from these two slides, 1, 2, and 3. So these three slides are very, very important. My dear, before I just go to that, could you please tell me what is the formula for Q? We use this formula from the in the previous chapter. What is Q?
Change in temperature
My
multiplied
m multiplied by
by
specific heat capacity multiplied by delta T. Am I right?
yes.
Okay, what is m?
Mass.
What is C?
See the specific heat.
Very good. What is delta T?
The change.
Change in temperature.
Okay, so this formula is applicable for solid or liquid. Am I right?
Yes.
If you have the gas molecules, how you can replace this formula, my dear? My dear, listen carefully. I am going to write the same formula for the gas. I am going to write the same formula for the gas, but I have to replace this m with small n. Clear? Understand? Because
Yes,
gas
doctor.
consists of n moles. Am I right or not? N number of moles the gas have. Am I right? The gas, you should not say the gas has the mass. You have to say the gas has the number of moles. Am I right?
Yes.
Okay. And the second thing, when you are about to find the molar specific heat, my dear, you have two cases. One is at constant volume and constant pressure. If you have a constant volume, you have to write this equation. You have to write this equation as constant volume, which is equal to n, and molar specific heat capacity at constant volume multiplied by delta T. If you want to write the equation for constant pressure, how you can write? QP which is equal to n CP
Delta T.
delta T. Clear, my dear? My dear, once you know this formula, these two formulas are very, very important, especially in this chapter. What is this CV? This CV tells you the molar specific heat at constant volume. And what is this CP? Molar specific heat capacity at constant pressure. You can see here, we are having the same formula here. Am I right? Am I right or not?
Yes.
So, my dear, how we got this rule? So, again, I have to recall the things what we studied in the last chapter. I told you to memorize the first law of thermodynamics. Am I right? What is first law of thermodynamics?
Q minus W.
Q, which is equal to change in internal energy plus work done. Am I right?
Yes.
If you rearrange this equation in terms of internal energy, you will get the same thing. Understand? Now you can see the picture. My dear, listen carefully. If you see the picture, I gave two curves. One is green color curve, another one is yellow color curve. Am I right? Am I right or not?
Yes.
And here I mentioned the point 1, 2, and 3. Now what I am going to do, for studying the concept of molar specific heat capacity at constant volume, you have to consider the number 1 and 2. In state 1 and 2, you can see, is there any change in the volume? In state 1 and 2, is there any change in the volume?
No.
So if there is no change in the volume, what is that?
Work
The
done
work
zero.
be zero.
So when you put work done is equal to 0, your Q is exactly equal to the change in internal energy. Am I right?
Yes.
So what is your Q? Your Q is this value. Am I right?
Yes.
So if your Q has this value, your delta E also have the same value. Am I right?
Yes. The same.
That's what we just write this, my dear. This formula is for the molar specific heat. So you can derive the molar specific heat at constant volume from this equation. So what you have to do, you have to rearrange this equation in terms of, for example, if you are asking the question, define molar specific heat at constant volume. So what you have to do, you have to rearrange this equation in terms of CV. So if you rearrange, what you will get, my dear? CV, which is equal to, you will get like this. Am I right?
Yes.
So this is the rule for molar. If you want to write the definition, better write this equation, explain each and every term. That's enough. Clear?
Clear. Yes.
Okay. Now let's come for the second part. My dear, in the first part we consider the point 1 and 2. But here what we are going to do, we are going to consider point 1 and 3. My dear, in point 1 and 3, what happened to the volume?
A change.
So if there is a change in volume, then we have
There
to
is
use
work
this formula. Am I right?
Yes.
So we have to replace this work done with the P delta V. And please, my dear, you can see here, I am just work out this problem step by step. When you just substitute the formula, because I am using the first law of thermodynamics, I am using the work done formula, I am using the formula for the constant pressure. That means the specific heat capacity, molar specific capacity for constant pressure and molar specific capacity at the internal energy. When you substitute all these things, you will get the relation Cp minus Cv, which is equal to R. Clear? Clear? If you just take a paper, if you just work out step by step, because I am not skipping any steps. If you take a paper and work just have a look, that will be quite enough. What is changing? Okay, my dear, listen carefully. What is internal energy? What is internal energy? We have this rule. Am I right? What is internal energy?
Yes. And
So I just use this formula. Clear? What is our QP value? QP value we have here. Am I right?
yes.
And what is P delta V? We already replaced this work done. Now, please rearrange this equation. And when you rearrange this equation, finally, you will get the term like this. Clear? Clear?
Clear. Clear.
Okay, now what you have to do, my dear, what you have to do, you have to use the ideal gas equation. So this is our ideal gas equation. When you just use the ideal gas equation, your term will be coming like this. Now, if you just see here, you can cancel some terms. You can cancel some terms. You can see here, I can cancel N with N. I can cancel N with N and P with P. Am I right?
Yes.
So what is remaining? The remaining term is Cp minus Cv, which is equal to R. Am I right?
Yes.
So this is one of the important rule, especially in molar specific heat at constant pressure. So Cp minus Cv, which is equal to R. Cp stands for molar specific heat capacity at constant pressure. Cv stands for molar specific heat capacity at constant volume. R stands for gas constant. Clear? Understand?
Clear.
Yes.
Clear.
Okay, my dear, listen carefully. Here I gave some numbers. Am I right? Here I gave some numbers. Am I right? Am I right?
Yes. Yes.
Yes.
Monoatomic. If you have monoatomic under constant volume, what should be the value, my dear?
3/2.
If you have diatomic, what should be the value for constant volume?
5/2.
If you have polyatomic, what should be the value of a CV?
7/2.
Okay, I'm going to write this value here. Could you please tell me what is the formula for CV, my dear? Just tell me. If it is monoatomic, it is 3/2 times of R. Am I right?
Yes.
Diatomic,
5/2.
5/2 times of R. Am I right? Triatomic, polyatomic, 7/2 times of R. Am I right? Okay. This is for constant volume, molar specific heat at constant volume. You will have this value for different shape object, different shape atomic structure. Now, my dear, if you have the constant pressure, how we got this equation? How we got this number? We got this number by using this equation. My dear, we just know Cp minus Cv, which is equal to R. Therefore, Cp, which is equal to Cv plus R. Am I right? Am I right? Okay,
Yes.
now for monoatomic, I am going to use this relation. For monoatomic, Cp, which is equal to Cv plus R. Am I right?
Yes,
Am I right? Okay, for monoatomic for Cv, what is the value?
3/2.
Okay, I can write here. For monoatomic, 3/2 times of R plus R. What should be the answer, my dear? Clear?
5/2.
So for monoatomic at constant pressure, you will get this value, but monoatomic pressure, monoatomic at a constant volume, you will have this. Likewise, if you substitute the value for each and every type structure, you will get this answer. Understand? Understand, my
Doctor,
dear?
do we have to memorize
Yes,
these
my dear,
numbers?
you have to memorize. Inshallah, when we are about to solve the problems, by the time you will know where we are going to use these rules. Understand?
Okay.
Okay. Now, let's become for our last slide. My dear, the last slide is adiabatic. Just before I told you, what is adiabatic?
No energy في اللو.
No heat transfer. Am I right?
Yes.
Okay. So, no heat transfer. What is your first law of thermodynamics? What is your first law of thermodynamics? Q, which is equal to change in internal energy plus work done. Am I right? Okay. If Q, which is equal to 0, your equation becomes 0, which is equal to delta change in internal energy plus work done. Am I right?
Yes. Minus work.
Therefore, my change in internal energy, which is equal to negative of work done. Am I right?
Yes. Negative.
So now, my dear, if you are using this equation, if you are using W, which is equal to P delta V, and when you substitute this equation in the first law of thermodynamics, you will get to two relations. The first relation connecting temperature and volume, and the second relation connecting pressure and volume. So if you have adiabatic expansion, you have two equations. My dear, listen carefully. 1 mark theory question. Write down the expansion for adiabatic for the ideal gas equation, or write down the adiabatic expansion of an ideal gas equation. How many equations you have? You have two equations. The first equation relates the connection between temperature and volume, and the second relation relates the connection between pressure and volume. How we got these things? We got this information from the first law of thermodynamics and the rule. So if you just see the second slide, I explain how we got this rule. So if you can see here, that equation is here. Am I right? Am I right?
Yes.
It is a simple mathematics rule. This is the simple mathematic rule. So my dear, listen carefully. You can just work out the step by step. So when you just work out, you will get the proof for temperature and volume. Now, my dear, listen carefully. We studied Cp minus Cv, which is equal to R. And here, for the easiest purpose, we put Cp over Cv, which is equal to gamma. So don't get confused about this gamma and the previous chapter gamma. What is gamma, my dear? In chapter number 18, we used gamma, which is equal to 3 types of alpha. Am I right?
Yes.
Chapter 18. Chapter 18. So here also we have one more gamma. What is this gamma? This gamma tells you the ratio between the molar specific heat at constant pressure over constant volume. So please, my dear, just have the step-by-step look, and then you can just, or you can just take a practice. In exam, we will never ask these things. Only information, we need the equation. So how we got this equation? I work out everything step by step. I didn't skip even a single step. If you just have a look, you will get a clear picture. Understand? Understand, my dear?
Yes.
So the main equation, first law of thermodynamics, the condition for the adiabatic, and the third one, the main equation for the work done. And also we have the internal energy. By using this 4 equation, we got this one. Clear? Clear?
Yes.
Likewise, if you work out for with the same thing for the pressure and volume, you will get the same relation. So if you want to get this equation, my dear, listen carefully. If you want to get the relation for pressure and volume, you have to take the temperature and volume equation. So if you want to get that relation, you must use this equation. So you can see I use the same equation. I took this equation, I put it here, and then I am applying the ideal gas equation. When I just rearrange this equation, I got the final expression. Clear? Clear, my dear?
Yes.
So
clear.
adiabatic, you have 2 equations. So now I think our chapter is over. Now I am going to recall the formula what we studied now. What's the time right now?
1:30.
Okay, 1:30. Still we have 20 minutes or 10 minutes? I think still we have 10 minutes. Am I right?
10 minutes.
10, Victor.
Okay, we can recall. Okay, what is the formula for number of moles? Now I need the answer from your side. What is the formula for number of moles? Capital N
Capital N
over, my dear,
capital
don't worry about this line, huh? Understand? I'm sorry because of this line. Okay, small n, which is equal to capital N divided by Avogadro number. Am I right? What is the formula for molar mass? Capital M, which is equal to small m multiplied by Ne. Am I right? Clear?
Yes, Victor.
Clear.
What
yes.
is K? What is K? Gas
R.
constant divided by Avogadro number. Am I right? And what is the ideal gas equation? PV, which is equal to nRT, or PV, which is equal to nKT. Am I right? Clear?
Clear, yes.
Okay. What is the formula for work done by the gas under isothermal condition?
Zero.
So work done, which is equal to nRT natural log of final volume over initial volume. Am I right?
Yes.
What is the formula for constant pressure? Work done, which is equal to P multiplied by delta V. Am I right? Am I right?
Yes.
And what is the formula for
Yes.
V square RMS? What is the formula for V square RMS? I think we studied 3 RT over capital M. Am I right? Am I right or not?
Yes.
Yes, Victor. Yes.
Therefore, V RMS, which is equal to square root of 3 RT over M. Am I right?
Yes.
And also, we have the kinetic energy formula. That means, what is the average kinetic energy? What is the average kinetic energy, my dear?
Half MV.
3 over 2 times of KT. Am I right? Am I right or not?
Yes.
Yes, Victor. Yes.
See here. Here. Okay. And then, what is the total kinetic energy, my dear?
3 over 2 nRT.
3 over 2 nRT. Am I right?
Yes.
Okay. And then molar specific heat at constant volume. What is molar specific at constant volume? Q divided by N delta T, or QV, which is equal to N CV delta T. Am I right?
Yes.
Am I right or not? And molar specific heat at constant pressure, Cp, which is equal to Qp divided by N delta T. Am I right? Therefore, my Qp, which is equal to N Cp delta T. Am I right?
Yes.
Am I right? My change in internal energy, is equal to N Cv delta T. Am I right?
Yes.
So, okay. Cp and Cv value. My dear, listen carefully. Cp, Cv and Cp value, monoatomic. This is 3/2 times of R. This is, what is this? This is 3/2 times of R. This is 5/2 times of R. Am I right? Diatomic. 5/2 times of R. This is 7/2 times of R. Am I right?
Yes.
And polyatomic. This is 7/2 times of R. This is 9/2 times of R. Am I right?
Yes.
Cp minus Cv, which is equal to gas constant. Am I right?
Yes.
And gamma, which is equal to Cp over Cv. Am I right?
Yes.
And then finally, adiabatic expansion, you have two equations. First one connecting temperature and volume. What is temperature and volume? T1 V1 gamma minus 1, which is equal to T2 V2 gamma minus 1. Likewise, pressure and volume. What you'll get? P1 V1 gamma, which is equal to P2 V2 gamma. Clear? Clear, my dear?
Clear, Doctor.
I think this many formulas we studied from this chapter. Inshallah, we are going to solve these 6 problems tomorrow, and we are going to use these formulas for solving these 6 questions. So, my dear, it's my kind advice to each and everyone. Tomorrow, I think we have the classes at 8th period. Am I right?
Yes.
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 In 2 p.m.
So before you come to the class, I think the slides right now available in your blackboard. Please take the print of this slide and please have a look of the problems. Okay?
Okay.
Clear? And inshallah, we are going to solve these 6 problems tomorrow. I think I will finish these 6 problems by tomorrow. So at least by this week, I have to cover these 4 chapters. Chapter 16, 17, 18, and 19. Clear? Clear, my dear? That's it. Chapter 19 is over. I think what's the time right now? The time is exactly 1:40. Am I right?
Yes.
Am I right or not? So, chapter is over. Any other question from your side?
Teacher,
Yes.
I have talked to you about the graph in the first experiment.
My dear, listen carefully, Mr. Abdul Wahab. I didn't receive any email from your side. I told you to send the email from your personal email ID. Am I right?
Yes, and I sent.
Did you send the email through your personal ID?
My own.
Okay,
email.
you can do one thing. Okay, you can do one thing. Scan the complete paper, okay, as one PDF file and send through WhatsApp.
I'm sorry that I have a problem in the internet. What did you say?
My dear, you can scan all these pages, including your graph sheet as one PDF file, and send me through WhatsApp. I will download from that.
Dr. Mustafa,
Yes.
I have problem on
Okay,
the
okay.
10
Thank
minutes
you.
on the first class.
10?
Yeah, the first 10 minutes because I didn't join because I have problem in
My dear, if you are late
application.
means because I took the attendance from the Blackboard. Blackboard
Yeah.
attendance I have to consider. Listen, if you are late means late.
Yeah,
If you are
yeah,
absent means absent.
but I think we have problem on the application of the Blackboard. It's
What
just,
can I do?
because
You can do one thing. If you have this type of issue, go to the student affairs and explain and get the attendance.
yeah, because I think you ask students have problem in the application. You need
My dear,
open
that's
the
what I
Safari.
said. That's what I said. My dear, if there is any problem in entering the attendance, I'm talking about from this week.
Yeah,
That week number 1, 2, 3 is already gone. Am I right?
yeah, doctor.
So I can't do anything. Better you can just focus it from this week.
Okay, thank you, doctor.
If there is any mistake, please immediately contact me during this week. If you contact after Sunday, please don't contact. I can't do anything.
Okay, I know, doctor.
Clear?
Yeah, clear.
Doctor,
Yeah.
Doctor,
Yes.
the Blackboard get me away for the last 5 minutes. I
Okay.
didn't know what happened.
Did you
That will
got the
make
mark?
me
Did you got the mark?
for what?
You are talking about the quiz, am I right?
No.
Ah.
About this lecture.
My dear, I told you, my dear, this information, I'm not related with these things. If the Blackboard kicked you outside, I am not responsible for that. Because what they told me, just enter the attendance from the Blackboard details. How I know you are just away. So you can do one thing after I enter the attendance. Listen, my dear, after I enter the attendance, if you have this type of issue, go to the student affairs and talk with him. I have no relation with this. Even I cannot be able to send the email. It's
Yes,
between you
I
and
mean, Doctor, all the lecture I was with you, just the last 5 minutes.
What can I do for that?
I mean, that will change me to absent or something.
But you can check in the educate what you got.
Okay.
You check the educate because you have to get the clear information from the educate, not from the Blackboard. Because we will enter the attendance to the educate. Clear?
Okay. When can I check now?
My dear, for the last 2 weeks, you can just go to your application. You can log into your SIS and then check the attendance. The details are there, or you can ask your friends.
Okay.
Clear?
Doctor,
Okay. Yes, my dear.
the last week, the attendance on Monday, you will change it because the quiz.
I gave present. Those whoever attend the quiz, I gave the attendance. So don't worry.
Okay, another question, Doctor.
Yes.
There's some question that came in the quiz. We haven't studied and even not in the slides.
Really?
Yup.
Okay.
And
Okay.
confused and got
You can do.
zero
Okay, my dear.
on it.
Excuse me, my dear. Listen. You have the discussion class by 3 o'clock. Am I right? Sorry, by 2 o'clock. Am I right?
Yes.
Yes.
Now by the time I will tell you the answer. Let's check whether it is in the slides or not.
From KBV.
I will work out.
Okay,
Don't
Doctor.
worry.
Okay.
I will work out. Don't worry. Clear?